Good morning, Math 8. All right. What we are going to do today is we're going to start off by working with reviewing over our converting standard notation into scientific notation and scientific notation into standard notation. It's going to be pretty simple. I'm going to do numbers 5, 7, 9, 11. 5, 7, 9, 11. Converting a relatively big number, a lot of digits in it that's a little goofy, into scientific notation. A decimal, again, a lot of digits, and then just two basic scientific notations, both a positive and negative exponent. Honestly, I said this in class, I said this on the video, converting scientific notation into standard form is usually the easiest thing to do for the most part. There's going to be some tricky things when we get into level 3, but this is just level 2 work. Level 2 work is just moving the decimal point. That's all you have to worry about. Here, they've done some things to mess with you. So let's do the 58240. 58240. Like I said on the video, I think I said this on the video, or I maybe said it in class. I like when there's a comma in there. I know they leave the commas off in here. They do that purposefully to mess with you, okay? I'm not lying. It was done to mess with you. So you have to figure out where the commas and decimals and all that kind of crap go. I know when I write this as scientific notation, I'm going to take the decimal and put it after the first non-zero number. So it should be 5.824. Now, in some of the cases, they will say round it to the nearest hundredth. So you've got to round it to the 2 here. So it would just round. It'd be the same thing. It'd be 5.8, but the 4 makes the 2 stay the same. So it'd just be 5.82. Okay, some of them will make you round it. It doesn't change the scientific notation at all, because the movement 1, 2, 3, 4 jumps to the end from where the decimal point was placed in your answer times 10 to the 4th. Okay, doesn't change this because there's a 0 there. It's still times 10 to the 4th power, regardless of if you round it or not. If they're giving you this many numbers, I say write that many numbers so you don't lop anything off. If they tell you to round it, just round it. Go to the digit they tell you to round to, look at the number behind it. Is it a 5 or above? That makes it round up. If it's a 4 below, it makes it stay the same. Okay, so basically you're just moving the decimal point in between the first and second number and then counting the spaces that you jumped from the original spot. So here, 0.7298. Same monster that we just worked with. The decimal points can be placed between the first and second number. So it's going to be 7.298. And it's always times 10. How many times did you have to jump that decimal? 1 time. But because this is a small number, okay, and if you move this one, if I'm going to move this one, it's going to move it to the left. That means it's a negative 1. I'll have to move it 1 time to the left. Now this one, if you round it, it changes drastically. 7 point, the 9, 8 makes the 9 round up to a 10, which carries over to here. This would be 7.30 times 10. And because it's 1 jump to the left to get to the original spot, it's a negative 1. All right, that is the scientific notation utilized from converting standard form into scientific notation. Now, to me, that is much harder than what I'm going to do next. Much harder. Converting standard form into scientific notation, you've got to take a lot of factors into it. How many digits there are in the problem, how many times you have to move it, multiply by 10 to the whatever power. In number 9, where it just says 2.48 times 10 to the 6th, it tells you everything. The decimal's here. You're multiplying by 10. It's a positive 6. So positive means you're moving the decimal point to the right 6 times. So 248, it's right here. 1, 2, 3, 4, 5, 6. This is your new decimal all the way here. Fill the blanks with zeros. 1, 2, 3, 4, 8, 4, 2. Bip, bop. So that number, 2.48 times 10 to the 6, is actually 2,480,000. Now, do you need this decimal point? Oopsie, do you need this decimal point at the end? No, it's not necessary. Not when you've got the right amount of digits and everything's in there. Okay, I'm not going to mention anything about the mistakes that people make on this because I don't want to get anything into your head that's negative. All you do is look, is it a positive or negative 6 right here? It's a positive 6. That means I move the decimal point 6 times to the right for your answer. Positive, right, negative, left. Count how many times it goes from there. Now the next one, 9.257. This one, obviously, they didn't round it. They put all the digits behind. Okay, 9.257 times 10 to the negative 2. It's a negative exponent. That means I move the decimal point to the left. How many times? 2. So I go to my problem. 1, 2. My new decimal point. A lot of people, when they rewrite this, don't put the new decimal point in. I say put it in. Honestly, put it in regardless if it's at the end or the beginning, so that you can fill this in and be correct with what you do. Okay? So, negative exponent, move to the left. Positive exponent, move to the right. That's how you do converting exponential values into scientific notation, and scientific notation into standard form. Standard, scientific, standard. Now, the next thing that we're going to work on or jump to is adding and subtracting. Let me put this down. Adding and subtracting with scientific notation. Key thing to be able to add and subtract with scientific notation, there's something that you need to have. And the good news is, with the stuff that you do on today's work, you will have it. You won't have to do any crazy work with it. You have to have common scientific notation values. So they both have to be times 10 to the fourth, or they both have to be times 10 to the negative second. Okay? Now, some teachers say, you know what? If you get messed up with scientific notation, adding, subtracting, just convert it into standard form and work from there. To me, that is a backup in this, that only if you're completely flustered and it's really tough would I do that, okay? Only if it is something that you just, I have no idea what I'm doing, then convert it into standard form and work from there. Otherwise, you're taking something that really isn't that horribly difficult and making it horrendously difficult. Now, what I mean by that, let's just start with an easy problem. 2.47 times 10 to the fifth plus 3.11 times 10 to the fifth. Okay, let me make that 5 better here so you can see it. All right, these two problems both have 10 to the fifth. You have to have common values there, or else you cannot add these two problems. Okay, it's like having common variables. If I have 3x plus 5x, can I add 3x plus 5x? Yes, they have common exponent or common variables. But if I change this one and make it y, can I combine those? No, they're not like terms, so I can't combine them. Okay, that's essentially what you're doing. If they have like terms, if they have like scientific notation, then all this is an addition problem. 2.47 plus 3.11. Boom. That's all it is. Line up the decimal. That's the only thing on these that you're going to get today for addition and subtraction. That is the only thing that will mess people up. That's the only thing that might mess people up. You have to line up the decimal points. 7 plus 1 is 8. 4 plus 1 is 5. Bring down the decimal point. 2 plus 3 is 5. And we already know that they are both times 10 to the fifth power. Done. Truly. If they don't have common scientific notation, you can't add them. If they do, all you do is add them or subtract them. That's all it is. Now they may mess with you, like on this one right here, and make it minus, and they may mess with you here, and it's subtraction. You can't subtract the way this is set up. This is now an integer problem. You have to take the 3 minus the 2, and it's going to be a negative answer in there. That's about the only thing that they can do with this that's going to mess you up, okay? I might do another one of these in class. I will do another one of these in class, but this is what we're going to be doing today. Adding and subtracting in the first half. Adding and subtracting scientific notation. Yes, we will be getting to multiplying and dividing later on in the day. All right, so good luck. Talk to you later. This is a 9 minute and 57